Hi, this is an example problem from chapter 14 on how to calculate the quantity of a substance. We're going to find out that the periodic table is very useful for allowing us to figure out conversion factors between the quantity or amount of a substance and the mass of a substance. In this problem, I'll pause for a moment and read the question. So we've got 55 kilograms of CO2 gas. Part A, we're going to use the periodic table. Well, I've shown you the two atoms that we're going to need anyways for CO2. And we want to figure out conversion factors for the CO2 molecule that's going to convert between number of grams per molecule and mass per single molecule, where the mass is given in atomic mass units U. So let me do the first one here. When you look at the periodic table and you see this number here, 12.0107, it can mean two things. That can be the number of grams per 1 mole of carbon atoms, or that could be the mass in atomic mass units, which we write as U, for a single particle of carbon. The same number is the same conversion factor in those two different sets of units. So let's go ahead and do this. We'll do for the first one. Now in this case, we've got CO2, right? So CO2, we're going to have one carbon atom, and we're going to have two oxygen atoms. So there's your molecule that has both of those. And we want to go ahead and calculate these things. So let me move this over just a little bit. So for carbon, that means to calculate, it's going to be, actually, I guess I'm going to just leave this off for now. So we're going to have one carbon, that means 12.0107. And then we're going to have two oxygen, so 2 times 15.999. And when we calculate that number, we get a value equal to 44.01. Now, if we want to use that number as a conversion factor between grams and moles, we're going to write this as 44.01 grams of CO2 per mole of CO2. And if we want to write this as the mass in atomic mass units, which the unit is U, then we're going to have 44.01 atomic mass units per each individual molecule of carbon dioxide. So those are the two conversion factors here for carbon dioxide. All right, in part B, what we're going to do here is we're going to compute the moles of the gas in 55 kilograms. So I'm going to take 55 kilograms and I want to convert it to moles, part 1. I've got a conversion factor right here, which is grams per mole of carbon dioxide. So I'm going to always need to convert this to grams first. So if I'm in kilograms, 1 kilogram, right? 1,000 grams. And then now the conversion factor to moles. Well, I want to cancel out the grams and I want to come up with moles. So I'm going to put the grams on the bottom, mole in the top. And we've set our conversion factors up correctly, I think. So let's go cancel out the kilograms, cancel out the grams, and we're left with moles. And that comes out to a value of 1,250 moles. And typically we call moles, we use the variable n. So we could write, in this case, n is equal to 1,250 moles of CO2. That's how much you have, how many moles you have in 55 kilograms. All right, let's look at part 2 here. It says compute the quantity of gas inside the balloon in terms of particles of gas. How many individual molecules of CO2 are there? Well, I do have this conversion factor, which is mass in atomic mass units to for each molecule. So I could convert from U to from kilograms to atomic mass units and then use that conversion. That's one way to do it. And in fact, let's go ahead and do that. We'll go ahead and do that just so we can see both ways. So say I've got 55 kilograms. I need to convert between kilograms and atomic mass units. Let's go ahead and look here. 1 U is this really small amount of kilograms, 1.66 times 10 to the minus 27. That's 1 atomic mass unit. Now we can use the conversion factor between atomic mass units and molecules. So 44.01 atomic mass units per molecule of CO2. Let's check that our units cancel correctly. Okay, cancel out the atomic mass units, canceled out the kilograms, and now we're going to get a number for the molecules. So it's a huge number, of course, because there's lots of molecules. 7.53 times 10 to the 26 CO2 molecules. And we usually write molecules, the number of particles, with a capital N. So we could write this as capital N is equal to this whole number. Now finally, let me show you another way to do the particles. That would be using Avogadro's number. So say we already know we got 1250 mole of carbon dioxide. Avogadro's number is 6.02 times 10 to the 23rd, and it converts between the number of particles and the number of moles, right? So let's go from moles to particles using Avogadro's number, just to see another way to do it. So I'm going to start with the moles, 1,250 moles of carbon dioxide, and let's use Avogadro's number. So 1 mole is equal to 6.02 times 10 to the 23rd. Particles, these particles are molecules, so we'll call them molecules. And if you do that calculation, you'll see that you end up getting the exact same number as we got in the previous way of doing it. So either way, we can get the correct answer here.